Last night for homework, you learned how to translate an image and you also learned how to reflect an image. Okay? When we translate an image, what does that mean when we're moving something through on a coordinate plane? That means we're sliding an image. Okay? We can slide an image up, we can slide an image down, we can slide an image up and left and up and right. That's usually how you would translate. Okay? If you wanted to reflect an image, that would mean you were flipping it across a specific line. The y-axis, the x-axis, y equals x, any line that I gave you. Okay? We have two last transformations we need to discuss. And the first one is rotations. Okay? Rotations mean I'm rotating a shape. So rotating means I'm going to spin an object around a specific center. So rotations, when you spin an object around a specific center. This is typically the origin. Okay? When we are rotating a figure, I can rotate it in 4 different ways. I can rotate a figure 90 degrees, which is 1 turn. I can rotate an object 180 degrees, which is 2 turns. I can rotate an object 270 degrees, which is 3 turns. And I can also rotate an object 360 degrees, which is back to where I started. Okay. Typically when we rotate an object, it's usually counterclockwise. Typically, rotate counterclockwise. Okay? So go ahead and take a couple seconds to finish writing this down and then we'll keep going. Okay, so I want everybody to look at this first example. Let's start plot a point to determine the relationship. So I want everybody to plot the point 5, 4, and we're going to call this point A. Okay? So 5, 4 is up here. Okay? Now when we rotate something, I plotted that wrong, that's 5, 5, sorry. 5, 4. I'm going to call that A. All right? When you rotate something, you're usually going counterclockwise. Now, I said above, we rotate 90, 180, 270, and 360. And we rotate in 4 sections because we have 4 quadrants. So if I was going to take A, and I was going to rotate it 90 degrees, I would spin my coordinate plane one direction that way. So let me show you over here. So I have our coordinate plane. Okay, oops, and I just erased it. All right, and I'm going to spin it 90 degrees. And you can do this with your paper, and you always turn it to the left. So I'm going to turn it 90 degrees to the left. Okay? So notice now it would be in what's called my second quadrant if I looked at this coordinate plane like it was perfect. Okay? This would be a 90 degrees rotation. So now let me rotate it 180 degrees. I'm just going to turn my paper one more time, which is basically turning my paper upside down. Okay? Now notice, if I pretended this coordinate plane was in the correct order, point A is now in quadrant 3. Okay? If I spin it one more time, that's 270 degrees. I'm still spinning my paper to the left, but notice it's now in quadrant 3. No, quadrant 4. Excuse me, it's now in quadrant 4. And if I spin this one more time to make 360, what do you notice? It's exactly where we started, okay? So I'm going to come over here and I'm going to write 90, 180, 270, and 360, okay? So we're going to start. We start at the value 5, 4, okay? I'm going to spin this object 90 degrees. And we're going to write down that ordered pair right there. This ordered pair is negative 4, 5. All right. So I want to determine a relationship between where I started and my 90-degree angle. Notice I took my x and y value and I flipped it, and then my x value became negative. All right, so now let's rotate it 180 degrees. Let me spin this one more time. It's now upside down. So now look and tell me what ordered pair this is. Well, that's -4, -5. Hold on, I might mess up. 1, 2, 3, 4. Oh, no, it's -5, -4. Okay? What's the relationship you notice between these two, 90 and 180? Notice my x value and my y value switched, and my x value became negative. It took the opposite. Okay? So now let's do this again. Spin it again. Let's make 270. Now I'm in quadrant 4. So now read, what's this ordered pair over here? Well, that's 4, -5. Now I need to determine a relationship between 180 and 270. I flip x and y, and my x value is the opposite. I flip x and y, and my x value becomes the opposite. All right, do one more. Go back to 360. 360. Notice it's in the exact same starting location, which is 5, 4. And again, if you switch your x and y value and you make your first value opposite, it's exactly where I started. All right? So whenever you rotate, you're flipping x and y, and then you're making the first value the opposite. Okay? So if a is 5, 4, I'm going to flip x and y and make 4, 5. And I'm going to make my x value the opposite, so -4. So -4, 5, that's a prime. I'm going to do 180 degrees. I'm going to flip x and y. So 5 comes down and -4 comes down. I take the opposite of my first term, so I make it -5. So -5, -4, that's a double prime. I want to rotate 270. I flip my x and y, -4, -5. I take the opposite of my first term, so instead of -4, it's now +4. This is a triple prime. Okay? So let's go ahead now and let's try this new ordered pair, -5, -3. So whenever you rotate, all you're doing is flipping x and y and making the first value opposite. Okay? So let's go ahead and plot this, and we're going to call it B. So I was able to erase mine off of my paper. Why don't you pick up a color and use your color to plot this point here? So I'm going to do all in plotting color. Okay? -5, -3. We're going to call that B. Alright? I want to rotate this 90 degrees. So I'm going to flip x and y, and I'm going to make my first one opposite to plot it. So now it's 3, -5. This is B prime. Notice it just moves one quadrant over. 90, 180, 270, 360. All right, now 180. Flip x and y. Make the first value the opposite. So 5, 3. That's B double prime. Now do let's now do 270. I flip x and y, make the opposite of the first one. So -3, 5. This is B triple prime. If I were to go all the way around to 360, I would flip these two again, and I'd make my first one negative, and notice that's exactly where I started. Okay? So let's write down our rule. Go ahead and highlight your box. Okay. Method. Take each x and y value and switch them. And then make first value in the ordered pair opposite. So if I start with just x and y, and I want to go to 90 degrees, I flip x and y so it becomes yx. I make the first one negative. If I want to go 180 degrees, flip x and y, make the first one negative. So it's negative x, negative y. If I want to go 270, I'm going to flip x and y again, so negative y, negative x. I make the first one the opposite. If I wanted to go 360, well, it's the exact same starting place. Okay? So go ahead and flip your paper over, and let's talk about actually rotating shape. We're going to rotate a triangle here. I'm going to rotate it 90 degrees, 180 degrees, and 270 degrees. So I didn't label this DEF, so let's go ahead and DEF. When you have a picture, it is really helpful to write down the ordered pairs first. So D, E, and F. So D is 6, 6, E is 6, 2, and F is 3, 2. Those are the ordered pairs of this triangle. If you want to get D prime, E prime, and F prime, you have to flip X and Y, make the first one the opposite. Flip X and Y, make the first one opposite. Flip X and Y, make the first one opposite. Right? So D prime is negative 6, 6, E prime is negative 2, 6, and F prime is negative 2, 3. And I very nicely wrote this on my coordinate plane, so I'm going to have to erase it so I can actually graph D prime, E prime, and F prime. So I'm going to do this. Alright, great. So now, E prime is negative 6, 6, E prime. E prime is negative 2, 6. And F prime is negative 2, 3. And notice, if you were to take this picture and you were to spin it to the left one, it would look just like this in quadrant 2, be pointing to the left. So now let's rotate this 180 degrees. So on D double prime, E double prime, and F double prime. So I take D prime, flip it, take the opposite of the first term. Take E prime, flip it, take the opposite of the first term. Take F prime, flip it, take the opposite of the first term. So now I'm good to plot. Negative 6, negative 2. And F is negative 3, negative 2. So if I were to take this picture and I were to spin it to the left 2 times so it's upside down, my triangle would be in the bottom left quadrant of this coordinate plane. So one more. Let's do E triple prime, E triple prime, and F triple prime to make it 270 degrees. So how we do this, we flip D prime, take the opposite of the first term. Flip E prime, take the opposite of the first term. Flip F prime, take the opposite of the first term. So now I'm good to go ahead and plot. 6, negative 6, 2, negative 6, E triple prime, and 2, negative 3 is F triple prime. And there I have it. So I want you to go ahead and pause this video, and I want you to try the next example on your own, and then when you're ready, we'll go ahead and go over it. So let's check out this next example. So I rotated 90 degrees. So I'm going to write A, B, and C because it helps. So A is 1, 4, B is 5, 0, C is 2, negative 3. 90 degrees is negative 4, 1, 0, 5, and 3, 2. So Negative 4, 1 is A prime. 0, 5 is B prime. 3, 2 is C prime. Notice that this triangle did not magically match up in one quadrant versus the other because it started out being in two separate quadrants. Okay? So now when you have to translate something 270 degrees, notice I'm skipping 180. So that's where the rules on the other side for 270, which is y negative x, really helps. It really helps if you have those written down like in the corner of your paper and you can figure those out, okay? So what this means is you take the original and you put y in the x spot. So y of A was 4. And you make the opposite of x in the y spot, so negative 1. And B double prime, I take the opposite, I flip 0 and 5. And then x has to become negative, so 5 becomes negative. And then C double prime would be negative 3, negative 2. So now if I go ahead and plot these, and I'll plot them in green, I have 4, negative 1 is A double prime, 0, negative 5, which is B double prime, and negative 3, negative 2, which is C double prime. And I'm going to connect my dots and go from there. So you're going to go ahead and pause this video, and you're going to practice those two examples on your own, okay? When you all are ready to go, we'll go on to dilations. So let's talk about what a dilation is. A dilation is when, not writing red, red, black, when you shrink or enlarge an image over a given center. Okay. So if you look, preview down below and you look at these pictures, notice P and P prime, they're no longer the same shape. One's large and one's small. I'm either shrinking or I'm enlarging. Okay? And how we shrink or enlarge is by what's called a scale factor. A scale factor is a ratio that compares the original image to the scaled image. Okay. If my ratio is between 0 and 1, my image shrinks. If my ratio is greater than 1, my image enlarges. Okay. So looking at these two examples down below, I want to know which one did I shrink and which one did I enlarge. So how you know this is you pick a point. So I see P. So now I'm looking for P prime. So going from P to P prime, did it get bigger or smaller? It got smaller, so I shrank this picture. Same thing over here. I see L prime, it gets bigger, I enlarged it. Okay. So let's now talk about the steps for solving a dilation type problem. You're going to like these, they're not too bad at all. 3 steps. Write down ordered pairs. Oops, I can't spell. Write down ordered pairs of original image. Okay. Multiply scale factor to each coordinate. Third step, plot new points. So if I look at this first example, ABC, I'm dilating around the origin with a scale factor of 2. So I'm going to write down A, B, and C. I want all those ordered pairs. A's ordered pair, -3, -2. B's ordered pair, 0, 3. C's ordered pair, 3, negative 2. So now I'm going to apply the scale factor to each. Multiply by 2, multiply by 2, multiply by 2, and that gets me A prime, B prime, and C prime. So when you multiply A by 2, you multiply both. So it would be negative 6, negative 4. B prime would be 0, 6. C prime would be 6, negative 4. So go ahead and plot them. Negative 6, negative 4, that's A prime. 0, 6, B prime, C prime, 6, negative 4. Connect my dots. Okay. If you flip over and you look at the next example, it says dilate the figure EFGH around the origin by a scale factor of 1/2. Okay? We're going to cross out where it says around the origin. That's not right because it's not centered with the origin. So we're just going to dilate it with the center. Around the center by a scale factor of 1/2. Notice this square isn't labeled. So EFGH, you always start in the top left corner and you go around a circle. Okay? So go ahead and write out all of your ordered pairs. And then I'm going to multiply it by my scale factor, which is 1/2. So E is negative 2, 4. F is 6, 4. G is 6, negative 4. And H is negative 2, negative 4. So I multiply by 1/2. Multiplying by 1/2 is the exact same thing as what? Dividing by 2. Some of you might say, well, what happens if I get a decimal? That's okay. You're going to get a decimal and then plot a decimal. So E prime is negative 1, 2. F prime is 3, 2. G prime is 3, negative 2. And H prime is negative 1, negative 2. So, go ahead. Negative 1, 2 is E prime. 3, 2 is F prime. 3, negative 2 is G prime. And negative 1, negative 2 is H prime. And notice I'm shrinking my image. Okay? So go ahead, pause this video, and try that next example on your own. And now I want to talk about the very last problem. Okay? Notice here it says I want to dilate it around point P. So I want everybody to highlight point P. Okay? When you have to dilate around an object around something that's not the center, all you do is determine the distance and apply scale factor. Okay? So I'm going to look at the distance between P and Q. That's 4 blocks. Now, yes, it goes up to 8, but you're still counting blocks. You're still going to get the same answer. So if I count up 4 blocks as my distance and my scale factor is half, what's half of 4? Well, 2. So I'm going to count 2 blocks, and there's Q prime. Okay? What about the distance between Q and R? That's 2 blocks. So if I half 2 blocks, it's 1 block. That's R prime. And then I do the same thing with S. P and S have 2 blocks between them. So 1 block is S prime. And because I'm centering this around P, P and P prime are the exact same ordered pair. And that's how I would dilate around something not around the origin. So this wraps up our transformations. We have 4 main types. To translate, we slide. To reflect, we flip. To rotate, we spin. And to dilate, we either enlarge or we shrink.